Soft PDF link is in the description and in the comment pin, and also there is a video that how to download the soft PDF. In today's video, we'll be discussing about atoms, molecules and stoichiometry from physical chemistry. So physical chemistry, atoms, molecules and stoichiometry. So relative atomic mass or AR. So relative atomic mass is the weighted average mass of an atom in a given sample of an element compared to the value of unified atomic mass. Let's suppose for helium, this is the relative atomic mass or the mass number or nuclear number, and this is the proton number or atomic number. So this is the proton number or atomic number, and this is the nuclear number or mass number. So the mass number of helium is 4, and the relative atomic mass is the weighted average mass of an atom. So weighted average mass of an atom in a given sample of an element compared to the value of unified atomic mass. And what is unified atomic mass? Unified atomic mass is 1/12 mass of carbon-12 isotope. So unified atomic mass is the 1/12 mass of carbon-12 isotope. That means the relative atomic mass is the average mass of an atom in a given sample of an element compared to the value of 1/12 mass of carbon-12 isotope. Then relative isotopic mass. So relative isotopic mass is the mass of a particular isotope of an element compared to the value of unified atomic mass. So relative isotopic mass is the mass of a particular isotope of an element, mass of a particular isotope of an element compared to the value of unified atomic mass. So for relative isotopic mass, suppose for chlorine, we know that chlorine consists of two isotopes, that is chlorine 35 and chlorine 37. So for relative isotopic mass is the mass of a particular isotope. That means the mass of a particular isotope. That means if let's suppose we consider the isotope as chlorine 35, then the mass of a particular isotope of an element compared to the value of unified atomic mass. And what is unified atomic mass? 1/12 mass of carbon-12 isotope. Then for relative formula mass or MR, the mass of one formula unit compared to the value of unified atomic mass. So the mass of one formula unit compared to the value of unified atomic mass, and unified atomic mass is 1/12 mass of carbon-12 isotope. So relative formula mass is the mass of one formula unit compared to the value of unified atomic mass. So the relative formula mass is the mass of one formula unit compared to the value of unified atomic mass. Then relative molecular mass is the mass of one molecule. Initially it is one formula unit, now it is mass of one molecule of a compound compared to the value of unified atomic mass. So mass of one formula unit, mass of one molecule of a compound, relative molecular mass, mass of one molecule of a compound compared to the value of unified atomic mass. And what is unified atomic mass? It is 1/12 mass of carbon-12 isotope. These formulas are needed for our calculation. For example, number of moles is equal to mass in grams by AR or MR. So number of moles is equal to mass by MR, and if we need to find the mass, then mass in grams is equal to number of moles into MR. So mass is equal to number of moles into MR, and number of moles is equal to mass by MR. Then number of moles is equal to number of particles divided by Avogadro's number. So number of moles is equal to number of particles divided by Avogadro's number. And what is Avogadro's number? It is 6.02 × 10⁻23 particles. That is, number of moles is equal to number of particles divided by 6.02 × 10⁻23. And what is number of particles? Number of particles is equal to number of moles into 6.02 × 10⁻23. Similarly, number of moles is equal to volume of a gas by molar gas volume, which is 24 dm cube or 24,000 cm cube. 24 dm cube or 24,000 cm cube. So number of moles is equal to volume of a gas divided by molar gas volume. Volume of a gas divided by molar gas volume. And what is the volume of a gas? Volume of a gas is equal to number of moles into molar gas volume. Volume of a gas is equal to number of moles into molar gas volume. Similarly, concentration in mole per dm cube is equal to number of moles divided by volume in dm cube. If it is concentration in gram per dm cube, then it would be mass in gram divided by volume in dm cube. But now it is concentration in mole per dm cube, so number of moles divided by volume in dm cube. Then for water of crystallization, we know that water of crystallization is the specific number of moles of water associated with a crystal. So specific number of moles of water associated with a crystal. For example, copper sulfate, and let's suppose the water molecule is 6H2O. So specific number of moles of water associated with a crystal. So let's suppose this is a crystal and this is the specific number of moles of water associated with this crystal. Now this is the water of crystallization. For example, copper sulfate reacts with water to form copper sulfate .5H2O, where this is the hydrated compound and this is anhydrous compound. Anhydrous compound, hydrated compound, and this is the water of crystallization. Anhydrous compound, hydrated compound, water of crystallization. Then for mass spectrometry, we know that chlorine exists as chlorine 35 and chlorine 37. So chlorine 35 and chlorine 37, chlorine 35 is 75% and chlorine 37 is 25%. That means in total there is 100% and the relative molecular mass of chlorine is 35.5. So the relative molecular mass of chlorine is 35.5. That means chlorine 35 is 75% and chlorine 37 is 25%. So if we just calculate, we would get a value that is 35.5, which is the relative molecular mass of chlorine. Now for mass spectrometry, usually we have given a graph like this or this type of axes and relative abundance and MR. Relative abundance means the percentage and MR. So relative abundance or percentage or MR. And for bromine, so first of all, the relative abundance against MR for chlorine. So chlorine 35. So chlorine 35 exists as 75%. So this is the percentage and this is the MR. So 35 as 75% and chlorine 37 exists as 25%. So 35 as 25%. Similarly for bromine, so first of all, for chlorine here we can see that the chlorine 35 exists as 75%. So its length would be 75% compared to this value, which is 25%. That means this is 25%, this is 50%, and this is 75%. So this length is 3 times this length. And if the length is 3 times this length, let's suppose we have given the relative abundance against MR graph and we have not mentioned anything. So we can easily tell that this is chlorine since this line is 3 times this line. That is, this is 75% and this is 25%. That means 1, then 2, then 3. Therefore, it is chlorine, which is 75% and 25%. So 3 times this line. Similarly, for bromine, here we can see that bromine 79 exists as 50% and bromine 81 exists as 50%. So 79, 50%, 79, 50%. Then 81 also exists as 50%. So if we calculate the percentage, then the MR of bromine is 80. 80 are given in the data booklet as 79.9. So it is approximately 80. That means 79 exists as 50%. So relative abundance or percentage against MR. So 79 exists as 50% and 81 also exists as 50%. So the length of the lines would be equal. That means the length of the lines would be same. And let's suppose we have given a relative abundance against MR graph and let's suppose these two lines are equal. Since these lines are equal, that means this includes that it is bromine since both are 50% or both are of equal length. And let's suppose if the lines are like this, that is, then this is also bromine since they are all 50%. So the two isotopes are 50% includes that it is bromine. And let's suppose it is 1/3 times the bigger line. So this is the smallest line, then this is another and this is another. So here we can see that the big line is 3 times the small line. So this includes that it is the relative abundance against MR graph of chlorine. That is 75% and 25% chlorine. You need to remember the formula, that is N is equal to 100 by 1.1 into abundance of M plus 1 ion by abundance of M plus ion. That is percentage or the peak of M plus ion by percentage of M plus ion. So N is equal to 100 by 1 plus 1 into abundance of M plus ion and abundance of M plus ion, where N is the number of carbon atoms. So you need to remember the formula, and as we do the past paper, you can use this formula to find the number of carbon atoms. From this example, here we have given the percentage abundance against atomic number. So we need to find the AR. So what is the AR? AR would be, first of all, to find the value of AR, we need to calculate the total percentage. So what is the total percentage? It would be 0.56 plus 9.86 plus 7 plus 82.58. So after calculating, we get a value that is 100%. So the total percentage is 100%. Then 84 into 0.56 by 100 plus 86 into 9.86 by 100 plus 87 into 7 by 100 plus 88 into 82.58 by 100. So after calculating the value, we get a value that is 87.7%, 87.7 as the total AR. Then for the next example, what is the relative atomic mass of gallium? So relative atomic mass, again, first of all we need to find the total percentage. So 60.11 plus 39.89. So the total percentage comes to be 100%. Then 60.11 by 100 into 69 plus 39.89 into 71 by 100. So we get a value that is 69.80 as the relative atomic mass of gallium.